Hello, health champions. Today I want to talk about the top 10 signs your kidneys are toxic or that they're losing capacity or degenerating in some way to make the rest of your body toxic. And sign number one is changes in urination. So what does a kidney do? Well, a lot of people look at it as just a filter, but that's a very simplistic way of looking at the kidney because a filter usually just catches certain particles and lets others through. But a kidney is very selective. It's an exchanger. It works both ways. So it can excrete things, it can let things out, but it's also capable of reabsorbing things that your body wants to keep. And a filter certainly can't do that. So in excreting and reabsorbing, it acts as a rebalancer. It rebalances blood glucose, it rebalances electrolytes, and it rebalances pH. So if we get kidney damage, now we can get leakage. Now the filter portion of the kidney starts getting holes in it, and certain things will get out that are not supposed to get out. And now we can get changes in frequency of urination, in amount, in color, in smell, and you can also get changes in cloudy or foamy urine. But it's also important to be aware that kidney damage is not the only thing that can cause this. And by far, the more common one, we call that a differential diagnosis or DDX, is if you have a bladder infection. If you have bacteria growing in the bladder, now they will produce things that can cause these changes as well. So as we go through these signs, we're going to talk about early, intermediate, and late stage signs. So the early signs would be when we have what's called chronic kidney disease stage 1 and 2. That's very early stages. And in stage 1, then we still have normal filtration rate, which means that it is equal to or above 90 milliliters per minute. So it's called stage 1, even though the filtration rate is normal, because there may be some other kind of issue going on, such as an infection, for example. So there's a problem, but the filtration is still normal. And what's a little confusing about this is that CKD stands for chronic kidney disease stage 1. But if you have normal filtration rate, then whatever problem you have is probably not chronic. So it's a little bit off to have that kind of naming convention because typically this is not a chronic problem. Now, when you get to stage 2 of CKD, now it tends to be more chronic, but it's still relatively early and not so serious. And when we have 60 to 89 milliliters per minute of filtration, now there is a mild to moderate reduction in this filtration rate. And eGFR stands for estimated glomerular filtration rate, which is the number you get back on your blood tests. But another confusing thing when you get your blood test back is that if you have over 60 and you're in stage 2 of chronic kidney disease, they're still going to call that filtration rate normal. So you can't just go by what the blood test tells you, like if you get a flag or not. You have to look at these numbers and understand what they mean. And if you want to learn more about how to read your blood work and really understand what's going on, I created a course for that, and we'll put a link down below for you. So the first sign that we talked about, the changes in urination, this would be an early sign. And I've started marking these in yellow just to indicate that it's a mild problem. It is kind of an alert. You want to start paying attention. The next early sign is hypertension. And here we're talking about electrolyte imbalances, because when we have electrolyte imbalances, we also have fluid imbalances, because water usually follows these electrolytes, especially sodium. So if we tend to retain or lose too much sodium, then the water is going to follow. And here I really want to emphasize the number one cause of kidney failure, kidney problems, kidney disease is insulin resistance. And part of this problem is that it starts affecting electrolytes, and part of it is that it causes microvessel disease. And the kidneys have lots and lots of these microvessels. because insulin resistance and high blood sugar causes swelling and fluid retention, and it disturbs the dynamics of tissues. And with insulin resistance, now we get an increase in sodium retention. We keep more sodium and we get rid of more potassium. So we change the fluid balance there. And we also affect something called the RAAS, which stands for renin-angiotensin-aldosterone system. So don't worry about the name, but what it is, it's a hormone system that through the kidneys and the adrenals, it regulates fluid. And with insulin resistance, we have a tendency to kick this RAAS into overdrive, and therefore we also increase the sodium retention. But insulin resistance also causes a low-grade chronic inflammation. That's where insulin resistance causes most of its problems, not just with the blood sugar issues. And this chronic low-grade inflammation tends to start affecting the blood vessels. So we get a reduction in vasodilation, meaning the blood vessels don't relax and let the blood flow through. And the opposite, of course, is vasoconstriction, where the blood vessels tighten up. So with insulin resistance, now we tend to have an increase in vasoconstriction, tighter blood vessels, which will also increase the blood pressure. But not only that, when we have vasoconstriction and reduced vasodilation, so the blood doesn't flow properly, now we get a reduction in blood flow to the kidney. And the kidney gets a lot of blood, but a portion of that is sort of directed off. It's siphoned off to feed the kidney tissue itself. So just like the heart that pumps all of the blood for the body, the blood that the heart pumps does not feed the heart itself. So the body kind of pulls off a little bit of blood on the side through the coronary arteries to feed the heart muscle. And the same thing works in the kidneys, that a portion of this blood that the kidneys process goes to actually feed and heal the kidney. So with all of these processes, now there's less blood flow to actually heal and repair the kidney. Sign number 3 is fatigue, meaning you don't have enough energy because you need oxygen to make energy. And kidneys also can be involved with anemia, which means you don't have enough red blood cells, you don't have enough hemoglobin, which is the oxygen-carrying protein that helps distribute oxygen to all the cells of the body. And the kidneys are involved with this because they sense how much oxygen is in the blood. And if you don't have enough oxygen, then the kidneys produce something called EPO, which is called erythropoietin. It's a hormone that tells the body to make more red blood cells. But if the kidneys are damaged, now they may not be able to make enough of this erythropoietin, and now we become anemic because we're not getting the signal to make red blood cells. Another way that we can get fatigue is if there is toxin buildup in the blood that starts interfering with the processes of the body. But this is probably not going to be a major factor in the early stages, but much more so progressively in the later stages. So then if this kidney disease progresses, now we can get into the intermediate stages, and this is called chronic kidney disease stage 3A and 3B. So 3A is when we filter 45 to 59 milliliters per minute, which means we still have more than half of normal filtering capacity, and there is mild to moderate damage to the kidneys. And then in stage 3B, we are filtering between 30 and 44 milliliters per minute. So now we're down to less than half of normal filtering capacity, and we have moderate to severe damage to the kidneys. And now it's really starting to become more of a chronic, serious issue. Sign number 4 is swelling and edema. So this could have multiple causes. One thing is, again, sodium-potassium regulation. As we retain more sodium, as we lose the ability to regulate these things, we can have increased amounts of water, fluid retention in the body. But then a second factor that kicks in more the more severe the damage gets, is that we could have a loss of protein. And the primary protein we're talking about is called albumin, which is the number one, the most prevalent blood protein. And all particles in the blood act like a sponge. They kind of hold water to them. And that's one of the main roles of albumin. But if we start losing albumin, if the holes in the kidneys, if the damage to the kidney is so large that we start spilling albumin, now we can't hold on to that water, and the blood pressure pushes the fluid out into surrounding tissues, and we get swelling and edema. And most of that is going to happen in the lower extremities, so around the ankles and below the knee, and that's because of gravity. So we have the blood pressure pushing it out, and then gravity is pulling it down. And sign number 5 is foamy urine. And if you recall, we already talked about that, but here it's getting more severe, and now it's usually more due to a progressively increasing loss of protein. Number 6 is muscle cramps. And as the kidney disease progresses, we could get a worsening of sodium-potassium regulation. And with that, of course, we could have a worsening of muscle cramps. So these are things that could happen very, very slightly, or they could become more severe and more frequent. So this is a problem that might start already in stage 2, but that could get really bad in stage 4. And we also want to keep in mind the differential diagnosis here, meaning what other things could this be? We don't want to jump to conclusions. Are we having these problems because of a kidney issue, or is it because we are deficient? Are we not getting enough electrolytes? Are we not eating the right types of food? Do we not have a healthy digestive tract that can absorb these? Or is it a problem with insulin resistance that causes us to not be able to regulate this properly? And now we're into the late stage signs. So now the color changed to red here, the outline of the letters, to indicate that this is getting pretty severe. And now we have stage 4, which means that we're filtering between 15 to 29, so less than a third of our normal capacity to filter through the kidneys. So now there is severe damage to the kidneys. And then in stage 5, we are filtering less than 15, so less than 1/6 of what we should be able to. And not just that, but now the kidneys are not functioning very well at all. Even when they're filtering certain things, they're not really reabsorbing or regulating much of anything. And this is usually referred to as end-stage kidney disease, that there's not much hope of this ever turning around. And our only hope now is dialysis or transplant. And with dialysis means you go to a clinic a couple of times a week and sit for several hours and have a machine filter out all the blood that you can't filter yourself anymore. So between visits, your toxic levels increase, and you have to be very careful with what you eat. And then you go to dialysis and they clean it out for you, and then you start over again. So sign number 7 is that you could get a metallic taste, and you could have the kidney filtration go so low, your kidneys are so dysfunctional at getting rid of toxins that you have a severe toxic buildup, and now that could start affecting and altering your taste receptors. Number 8 would be a loss of mental sharpness. So again, you have decreased kidney filtration, you have excessive toxic buildup, and now that interferes with the metabolic processes of virtually every organ in your body, including the brain. So now your brain isn't able to signal properly, it's not able to make energy the way it's supposed to, and you start noticing a severe lack of focus and concentration, and basically all your mental capacity goes down. And then number 9, ammonia breath. The mechanism is the same because the kidneys are not filtering, toxins are building up. And one of the primary things that the kidneys are supposed to get rid of is urea from the urine. That's why it's called urine. It contains something called urea, that if this starts building up, it converts to ammonia. And if you can't get rid of it the way you're supposed to, through the bladder, through the kidney, now your backup system to get rid of things is through the lungs. So you start breathing out toxins. And number 10 is shortness of breath. And here it's very interesting because there's several mechanisms that contribute. And I'm mentioning these just to help you understand and appreciate the miracle that the body is. So first, we have the sodium-potassium regulation, that if we're not handling that properly, we could get an increase in fluid retention. And then that could work together with mechanism number 2 of loss of protein that can also cause fluid leakage. So between the two of these, we get fluid leakage that starts leaking out into tissues where it doesn't belong, including the lungs. And if it gets into the lungs, that's called pulmonary edema. And the inside surface of the lungs, which by the way, if you lay it out, it's something like the size of a basketball court. It's supposed to be moist, but it can't be wet. So if it starts filling up with fluid, now you get a reduction in the surface area, the area that's available to absorb oxygen. And of course, if there is less surface area available to absorb oxygen, now you have to start breathing faster to compensate. The third mechanism that contributes is anemia, which we talked about. If we can't make enough red blood cells, we don't have the oxygen distribution system in place. So now we have less absorption area, we have less distribution, so of course we're going to start breathing faster. And the fourth component here is called metabolic acidosis. So one of the things we said the kidney does is it regulates pH, or acid-base balance. And if the kidneys don't work properly and we start becoming very acidic, then one way the body tries to deal with that is to breathe off some of that acid. So when we eat food and we oxidize that, we use oxygen to turn the food into energy, then we break it down into water and CO2, carbon dioxide. And that carbon dioxide is very acidic. So when we get acidic, then the body tries to increase the breath rate. We breathe faster to blow off more of that carbon dioxide to get rid of some of that acid. So all of these four things can contribute to a shortness of breath, and all of them can have to do with kidney function, but probably only in the very late stages. And I wish I could convey how important prevention is when it comes to kidneys, because everything in the body is along a spectrum. It's a gradient of function, a gradient of severity. And the number one thing that we want to do to prevent this is to avoid insulin resistance. Just learn what it is. I've done hundreds of videos on it. Learn what it is, how to avoid it. And the number one way is to reduce processed foods. Now, I've done hundreds of videos on the details where you could learn more, but we'll just keep it real simple here. So in the early stages, while we're kind of on the green and the yellow side of the spectrum, in stages 1, 2, and 3A, now the chances of reversing this are really good. You take some supplements and you avoid processed foods, you learn how to eat healthy and live healthy. And some of the supplements that I use in the clinic that works really well are from Standard Process. It's called Renatrophin PMG. They're called RenaFood and Arginex. And I'll put some links down below for you. But then if we have progressed further already, if we're already on the second half of the spectrum, we're in stage 3B, then now it gets more iffy. There's still a pretty good chance, but you really have to take this seriously. And supplements may help, but you probably also want to be under pretty close supervision of a doctor who can monitor this for you. And then if we get into stage 4, it's not absolutely hopeless, but it doesn't look real good to be able to turn this around. And once you're in stage 5, for the most part, it's going to be too late. I would never say never, but typically it's going to be too late at that point. So prevention means that you understand this stuff before you get into deep trouble and you do something about it early. If you enjoyed this video, you're going to love that one. And if you truly want to master health by understanding how the body really works, make sure you subscribe, hit that bell, and turn on all the notifications so you never miss a life-saving video.